You all want to start with the Bernoulli?
Yes, sure.
All right, let's do a Bernoulli. So this is 2.5, number 9. So I wrote it down and prepared. I'm prepared. 2.5, number 9. So we have dy dx. So I haven't done this since you've done it. This is going to be fun. I just wrote it down like I haven't done it. Equals.
Real quick.
Uh-huh.
On those videos that I was watching.
Uh-huh.
When you had you're working all the way on the left side, I could barely remember.
I know, so I'm going to stay here. Yep, I know. Yeah, if I go that far, you can't see it, right?
But over there you can.
Over there you can, right? Here it's good, right? But over there, for some reason, yeah. Yeah, gotcha. Yeah, I'm aware of it. Boom. So this one is Bernoulli, and you know it's Bernoulli because anyone know why? Why is it?
Y to the 5.
Y to the 5, yeah. Whenever you have y to a power like this, you know it's going to be a Bernoulli. So the first thing you want to do is distribute the y and keep that y to a power on this side and get everything over here. So distribute the y, so we have dy dx. dy dx equals, so we'll distribute the y, so y times this, we get xy to the 6, yeah, wow, I just woke up, still waking up, and then y times -1 is negative y, yeah, negative y, and I have the problems written down here, but I haven't done them, so this will be interesting. So we're almost there. We need to get this on one side by itself, so maybe just add the y to both sides, so plus y, plus y. On the exam, look for this. You should have a Bernoulli, right? So this is going to be dy dx plus y equals x y to the 6. So now it's like in the standard form, right? So we have dy dx plus y equals x y to the 6. It looks kind of funky to me, but it looks, yeah, that's what's in my notes. Yeah, I don't need this anymore, so there's nothing else there. So, any questions so far? Okay, so now we have to identify n. So obviously, what would n be in this case? 6. I'm going to write it way up here, so I'll just do this like to separate stuff. N is 6. And the formula is this. It's u equals y to the 1 minus n. That's what you want to work out next. So identify n, and then you work out u, okay? And you just go, it's very procedural. Like once you know the steps and once you can do one of these on your own, if you can redo this when you're ready for the Bernoulli, right? There's only 2 Bernoullis in the homework, I think, right? That I assigned as like review questions, yeah. Okay, so n is 6, so this is y to the 1 minus 6. So it's y to the negative 5, right? 1 minus 6 is negative 5, right? 1 minus... You can solve for y by doing a bunch of work, or you can do it in one move by raising both sides to the negative 1 over 5. Good, Kenny. So you just do this like this. Very good. And then negative 1 over 5. Beautiful stuff, right? So these cancel. These cancel. So I'll go ahead and put the y here on the left-hand side. So y equals. And just as a warning, if you watch the videos that are in the homework, the book does it differently. So the videos are probably different as well. I have not watched the videos. I don't know. So we're here. So first thing you do is you isolate, this piece by itself, identify your n, work out u, and then you solve for y. You solve for y. Okay, so now we have to find dy dx, right? So dy dx. So here's the thing. I'm going to write it again up here. U is equal to y to the negative 5, right? Y is a function of x. Therefore, u is also a function of x, right? So when we take this derivative, we have to use the chain rule, right? U is our inside function. We bring down that negative 1/5 like this. Then we get u. So negative 1/5 minus 1 is negative 1/5 minus 5/5, negative 6/5 times, anyone know? Du dx, good! That's the chain rule. Yes, that's exactly what it is. So don't forget the du dx. It's the derivative of the inside. If you're confused, just memorize it. It's terrible advice, but it'll work. You'll get the right answer. So, because if it's not there, you'll get it wrong on the test.
You're confused about what?
If y it's there with the du dx.
For the chain rule, you take u and replace it with x, differentiate with x, now you have u as a separate function, and du over dx is what that is.
That's the derivative of u with respect to x. Yeah. It's like if you had, I'm going to erase this, but I'll write it. I'm just going to erase it. Say you had x squared plus 5 to the negative 1/5, and you took the derivative, you would get this, negative 6/5 times the derivative of this. If this is u, its derivative is 2x. That's du dx. Yeah, totally worth it. Good. Yes, it's worth it. Most people don't understand, they just memorize it, which is fine, but it's better to understand stuff. I like drawing these lines. It makes it easier for me to see. Any questions so far? The next step, we're just going to substitute, right? All right, so now we're going to make a substitution. So now we go to this one, and we're going to replace everything. So dy dx is this piece here. So this is going to go here in this piece here, okay? So it'll be negative 1/5 u to the negative 6/5 du dx. Oh, I'm glad I left some room there. That's good. I didn't do that on purpose, but that worked out.
So we're going to plus y.
Plus y. Yeah, u to the negative 1/5. And then that's equal to x times y to the 6. So it'd be 6/5, right? Because if u to the negative 6/5, because you have y equals u to the negative 1/5, so it'll be u to the negative 6/5. Feels like it's easier to see in this room than the other room, right? It feels, doesn't it? Does it feel easier? I feel like, oh, you're closer. That's what it is. Because usually, I feel like it's a smaller room, but it's not.
We'll try that minus y.
What minus y?
With the x to the times u to the negative 6/5.
Yeah, that's from this. Yeah, because y is this. So when you raise it to the 6th power, you get.
Oh, I see.
Yeah, no, it's worth it. So you would get that, and then 6 times negative 1/5 is negative 6/5.
Oh.
You see it? You see it?
Oh, I have to do it in standard form.
Yeah. You have to go back in here and do it. Let me pause.
I was trying to plug it in.
Yeah, no. Oh, right. That could cause problems. Yeah, go back to this one. Go back to this one. Any questions so far? So far, you think you could do it again? Like maybe? Okay, all right. So now we have to make this a 1. So you might say, oh, divide. You could do that, but that's hard. So the way I do it is I do this. I write down what I have to multiply by to make that a 1. That's just the way I do it. So mult by.
Negative 5 u to the 6 and the 5.
That's how pros do it. Very good, Kenny. Right, so the negative 5 gets rid of the negative 1/5, and the u to the 6/5 makes that cancel, right? Because when you add 6/5 to negative 6/5, you get u to the 0, and u to the 0 is 1, right? So I usually do this, and then I perform the multiplication in our heads. So this times this, it cancels, so we're left with du dx. Okay, so du dx. Minus, is it minus? Minus 5 u. We did it right. Yes. If this is not a u, game over. So let's check that. So 6/5 plus negative 1/5 is 5/5, right? Because when you multiply these, you add the exponents. So 6/5 plus negative 1/5 is 5/5. So that's 1. And this is equal to, I forgot what we're doing.
No,
Negative 5x. Yeah, because these completely cancel, right? The u to the 6/5 and the u to the negative. It's beautiful. This is kind of fun. It's been a while since we've done this. Kind of like this. It's kind of exciting. It feels like a step up from series, right? Like, even though it's the first test is the worst, yeah.
Can you re-explain why you multiply by negative 5 u to 6/5?
Yes. So it's based on this. Very good question. So the goal is to make this a 1. So to get rid of the negative 1/5, we're using negative 5. And then to get rid of this, we have to multiply by u to a power so that when we multiply and when we add, we get 0. So 6/5 plus negative 6/5 is 0. So if it was this, let's pretend it was this, du dx. Then you would do negative 3u to the 2/3. Hey, Jeff! So you would do that.
2/3 are going away because we're the top one on the bottom.
When you multiply u together, it's not u to something with an exponent.
You're adding.
U to the something, and the exponents add.
Yes. The exponents add. So it's 2/3 plus negative 2/3, which is u to the 0. No, it's worth it. It's worth it. Ask. We're almost there, kind of. Yeah, kind of. I'm thinking, okay, I know what to do. So now it's linear, right? Now it's linear. So now we have to find our integrating factor, right? And that was e to the integral of big P. And this is always your big P, okay? So mu of x is equal to e to the integral of negative 5 dx. right? This is called the integrating factor. This is linear. You'll also have a linear one on your test. So by doing this problem, in a sense, we're doing two problems in one. I almost started with the linear. I thought, no, it's too easy. Let's start with this one. That doesn't mean you shouldn't study the linear ones, right? Make sure you do those review questions. Like, okay. Huh? If you can't do the linear, you can't do this. But it's still worth doing the review questions, trust me. Like, it's worth it. Yeah, that's totally worth it. So this is going to be e to the negative 5x. So that's our integrating factor. And I say it's worth it because you get integrals and stuff. Like when you're doing the homework, you might know the steps, but you might get, like Levi said, some funky integral. Like, and by doing the homework problem, you'll be able to do it again on the test. So mu of x is equal to this. So I'm going to put this in a box. That's not the answer, but that's our integrating factor, right? So now we're going to take this and multiply each of these terms, right? Multiply the whole equation by e to the negative 5x. Yeah?
The integral above the e, why is that negative 5?
It's this p. It's whatever is here.
Okay, but wouldn't you do negative 5u?
No, it's always with respect to x in this case, because it's dx. It's du dx.
Okay.
So if it was like dr d theta, it would be d theta.
Okay.
If it was dy dt, it would be dt.
So you just take the coefficient of u,
Right.
p of x,
That's your p of x.
and then p of x multiplied by the differential dx because the whole
That
equation
variable is
is
x.
divided by d of x.
Right. Yeah. This variable is x. Yeah. What's it called? The independent one. Right. I had to think of the fancy name for it. Okay. So we multiply everything by this. So this is going to be e to the negative 5x du dx minus 5 e to the negative 5x u equals, oh, this problem is super awesome. Oh yeah.
You're always going to end up with du dx.
Tabular on the right. Yeah, you're always going to end up with something here. All we did so far is put this here, and then put this here, right? This piece, Isaac is right. This is always magically going to be d dx. Integrating factor times u. So I don't know which one we put first. I'll put the integrating factor first. So e to the negative 5x times u. And that's equal to this. We'll check that in a minute. So this will always be the case. Yeah, Levi?
You're not sure, can you just look at it as the reverse of the product rule?
Yeah. Yeah, that's what we're going to do now. We're going to check. So yeah, let's check this. So this is the product rule, right? So it's the derivative of the first. So the derivative of e to the x is e to the x. So it'll be e to the negative 5x times negative 5. That's there. Times the second plus the first times the derivative of the second. Let me do it again. The derivative of e to the x is e to the x. So it's e to the negative 5x times negative 5. Boom, there it is. That's derivative of the first times the second plus the first times the derivative of the second, right? So it checks. You can always check. You should always check if you want to. You don't have to. You can just take a chance and just live dangerously. But it's up to you, right? It's your choice, right? You can just... So now, to get rid of the ddx, what do we have to do to both sides? Integrate. Yeah, integrate. Everyone okay with this? Everyone okay with this piece? So it's all, you just memorize it. It's always mu of x times u. Okay, it's just memorized. Okay. So integrate both sides. I'm just going to put integrate. Integrate. So when you integrate the left-hand side, the d dx goes away, right? So we get e to the negative 5x times u. And I'm just going to go ahead and put the integral sign here, negative 5x, e to the negative. That's tabular. Yeah, you can use parts or you can use tabular. Let's go with tabular just because it's way faster to do tabular. It's too early for parts. I had breakfast hours ago. Okay, so let's use tabular. So tabular, you can use tabular whenever parts works and whenever one of the factors is eventually 0 after repeated differentiation. So negative 5x is eventually 0 if you keep differentiating it. So write that piece down. I love tabular. Oh, this is so much fun.
Sometimes though, if one of them won't go 0, but you don't really want to do it because the other one's super hard to integrate.
Right. Then you just, give up. No, don't give up. So take the derivative again. So it's negative 5. One more time and you get 0. When you integrate this, you just keep dividing by negative 5. Yeah, you're ready for the test. Negative 1/5 e to the negative 5x, and then 1 over 25. Remember, there's a thing called partial credit, too. So, the further you get on every question, the most important thing is that when you do this question, You don't say, oh, it's a homogeneous, let me do it that way. It's not, so that would be bad. so if you take the right approach, you get, a lot of effort points. What do you start with, plus or minus? Plus. So plus, minus, plus. And then you draw the arrows, right?
This one might be easier. Just go ahead and change those signs. See how it's like a negative and a negative?
Yeah, it's going to become positive.
Call that a plus. And then erase the other two.
Well, I don't want to erase, but yeah. I'm always scared to erase in class. Because then you go home like, oh, did he erase it? Like, I used to have this teacher, he would erase with his hands, and it was really confusing. Okay, so this times this, these cancel, right? You're right, it's positive, so it's going to be
X times e to the 5x.
x times e to the negative 5x, and then plus again, right? 1/5. 1/5. Oh, this is so awesome. 1/5 e to the negative 5x. Now we can add our c, so plus our constant c. Let me pause here. It's only been 16 minutes, which is okay, 17 minutes. I don't think we'll be able to do everything I wanted to do today, because but it's all right. It's all right. I got a list. Let's just.
Is your class after?
Yeah, after this, right after class, I have to leave. I'm going to go eat. Then I have another review after this, Calc 1. It's longer, though. It's a longer review. Okay, so now we're not done, right? We have to replace u with what it is. So where is u? Oh, my God. It's right here. I remember there was a reason I wrote it again. I see, said the blind man. So u is equal to y to the negative 5. So we have to plug that in. Okay, so it's going to be e to the negative 5x. Over y to the 5. I'm bringing it down, right? Because it's y to the negative 5. So I'm bringing it down equal to x, e to the negative 5x, plus 1/5 e to the negative 5x, plus c. Okay. Unfortunately, on the test, the directions say explicit solution, so we have to solve for y. I really don't want to solve for y. We have to multiply by y to the 5th and divide. I could just say don't worry about it on the test and just leave it as explicit. You want to do that instead? Oh, let's do that then. Yeah, so who cares? So we're done, right? So on the test, if it says explicit, just leave it as implicit. Yeah.
Just to make it easier to write, should you divide by like e to the 5x?
Very good, Colin. Colin is right. To make this look more beautiful, we can divide by e to the negative 5x. So it's gone. Oh, fail. And then plus.
That would have been points in the final. That would have been a big deal.
Oh, I don't mess up in December. And then you can bring it up and make it positive, but I'll just leave it there. So.
You wouldn't give us any points off if we left it.
No, I wouldn't. So. Yeah.
On our final as well today, we don't have to do.
You don't have to solve for y. Don't worry about it. So I'll remind me to tell the class. On any of them. One of them is fill in the blank, so you do, but it's easy. It's not like this. Well, I think it is. But the other ones, just if it says explicit, just don't worry about it. It makes it easier to grade too. A lot of people forget to solve for y. It's not that they can't; they just forget. So. Kind of sucks to lose 3 or 4 points because you forget to solve for y. So now you don't have to worry about it. So, any questions on the Bernoulli? It took us 19 minutes. Yes, Vincent.
For the mu integrating factor, why is it negative e to the negative 5 dx?
This or this one? This one? Yeah. Okay, Vincent. It's always going to be e to the integral of p of x dx, and your p of x is negative 5.
Is that coincidence then that it's negative 5u and negative 5x, or is it both going to be the same?
It's always going to be whatever's there.
Oh.
So like, let's say Vincent, I know it's hard to see over here, but oh well. Let's say it was x squared y equals 2. In this case, it would be e to the integral of x squared dx. Whatever is there.
Okay.
You see it now? Yeah. You sure? Good. Good. All right, so what do you want to do next? We can do a homogeneous one?
Yeah, first order homogeneous.
Just do what was the other thing you said? First order homogeneous. Yeah. Like the way you said it. Okay. Yeah, let's do a homo from the first test, right? Homogeneous from the first test. Yeah, the second test doesn't. Yeah, here we go. This is 2.5, number 3. 2.5, number 3. I just picked one, right? This is random. So y squared plus yx dx. I think these are the hardest ones. Yeah, emphasizing the first test because your first test, because of the hurricane, was a take-home test, right? So, So this test might seem really tough. Make sure you study, okay? Like, please do the review questions, right? Usually in a regular classroom, like the first test is pretty rough. Like, people get bad grades. Okay, but I shouldn't say that. So there's two choices. You can do x equals vy, in which case dx equals v dy plus y dv, or you can do y equals ux. I'm having to dig deep here. Yes, Matthew.
When you looked at the Bernoulli, you saw that y to, I believe, the fifth made it clear that that particular problem was Bernoulli. How do I identify this particular problem as homogeneous?
Thank you. Yeah, so how would you even know this is homogeneous? That's a really good question. Yeah.
It's supposed to be y is equal to dx.
Does it even matter though?
That's a u. That's a u. That's a u. That's a u. It's just a bad v. Sorry. It's a y equals ux. I'm sorry, my handwriting is bad. I used to do it like this. Then it was really like uv. Okay. It's just, Matthew had a really good question. He says, how do you know it's homogeneous? This is really important for the test. Well, the best way to know it's homogeneous is that you studied so much that when you're taking the final, you'll be like, oh, that was in the review, so like you're ready. That will probably happen if you study. But the real way to tell, that will probably happen to you. It's very, you'll see. But you look at the exponents, right? 2, 1 plus 1 is 2, 2. They all have the same exponent, right? And you can mix exponents. That was the trick, right? So 2, 2, 2. So see how there's a 2 there? And then 1 plus 1 is 2.
Okay.
They're both 2s, and there's a 2 here. So it's homogeneous.
It's like homogeneous for every variable. Multiply by variable. If you combine the powers, it's going to be the same.
Yeah, so like this would be homogeneous as well because they're both 3s, right? But if I do this, game over.
Yeah, and you can have like a y, an x, and a w or whatever.
Right. Right, I could do this as well. That's also homogeneous because 1 plus 2 is 3. Right, 1 plus 2 is 3. Okay. Which one is easier, x equals vy or y equals ux? Y equals ux. Why? Can you explain why?
Because if you put the one with dx in here to multiply, you're going to do this crazy.
Yeah, I agree. Yeah. So if you do this, you have two things here, and you put it here, and you have to FOIL. Like, So it's better to do this one. So we're going to do this one. So solution. SOL means solution. So we have y equals ux. I'm going to write it again. And so that means that dy equals u dx plus x du. Focus on my u's.
If we switch the v and u on the two.
It's fine. Yeah, it'll just make it confusing for me. Just get it right, Kenny. Okay. It's just That's the best. Please try to get 100. It makes it easier to grade. So now you just plug everything in. So ux squared. So it's going to be u squared x squared. I just said skip that step? Okay, I'll do it. I wasn't going to, but since Veronica said it, so ux times x, I'm not going to skip that step. I feel guilty. I just feel wrong doing it. I won't do it. Right? It's just ux squared, right? But it's ux times x. I've been burned too many times on these. Minus x squared. I think these are the hardest ones on the first test, the homogeneous. Like, it's just really, if you mess up here, it's like you'll get it wrong, right? And then dy is here, it's right here. So it'll be u dx plus x du. And that's equal to 0. It's equal to 0.
So right now we're just plugging stuff in?
Yeah, we're plugging stuff in, and then it becomes separable. So basically, after you do this, it becomes a separable differential equation. So this will be u squared x squared plus ux squared dx, right? And then minus x squared u dx, right? I think I did that right? Yeah?
I know there was a method to why you chose y equals ux, but can you explain why you chose that one instead of the other?
Yeah, let me finish so I don't mess up. X cubed du equals 0. That times that is x cubed. Yeah, because Isaac said so. And because the real reason is if you use this one, there's two terms here. And then when you put it there, you have two things times two things. So it's harder.
Okay.
Right? So if we do this one, it's just x squared times this. It's easier to distribute. But you get the same answer either way, Matthew. So yeah, you get the same answer either way. Yeah. Okay, what do we do now? Just distribute. So this is, yeah, Levi?
doesn't the u x squared u dx cancel?
Yeah, I'm going to write it again. I think you're right. I'm just going to show one more step. And I think, just writing it really fast. I think you're right. So I just rewrote it one more time. And it does, right? These middle terms go away, right? That's a good sign. Sometimes stuff doesn't cancel, right? Is that a bad sign? No, it's just sometimes stuff happens, right? So, all right. So now I'm going to add this to the other side because this is going to be a separable differential equation. So we have u squared x squared dx equals x cubed du. So we're here. And we want to separate it, right? We want to get all the x's on one side with the dx and all the u's on one side with the du, right?
So dx over x equals du over u squared.
Yep. Very good. So divide by x cubed. That will give you dx over x. Yep. So pros do. And then over here, du over u squared. Yep. Which is u to the negative 2 if you really want to skip a step, right? Because we do have to do what now? Integrate. Very good, Jeff. Like a pro. On fire. I never see you this early. You look different. That's good.
I look different.
No, smarter. Yeah, you do. Sorry.
Oh my God.
It's too early. Yeah, the night class people don't wake up till 4. No, I'm kidding. No.
What did you do there?
Divided by x cubed.
Okay.
So we got x squared over x. Yep. And then brought that over there.
Got it.
So now we get to integrate. So divided by x cubed. X squared over x cubed is 1 over x. Divide by u squared. Before I integrate this, though, what do you have to do to this one to integrate it? Bring it upstairs. Yeah, bring it up. So this is going to be u to the negative 2 du, right? U to the negative 2 du. This is not so bad. Like, that's because you're helping me, right? Like, so this is going to be ln absolute value of x, yep, equals u to the negative 1.
Well, you still can add it on the other side.
Plus c.
You see it? No. You know, you can just, as long as you add it on one side. I had a girl in my class once. She would do this every time. She'd put teeth in it and stuff. I don't know. I thought it was funny. She did all right. She should have gotten an A. Okay. So this is ln. She never did the homework. Equals. This is negative 1 over u. Okay. Plus. C. I am so glad we don't have to solve for y. I'm glad I made that rule. It's great. It saves us like 15 minutes of review time. That's why I did it. We're almost done, right? U is somewhere. It's right here. Y equals ux, right? Or here. So that means u is equal to y over x, right? So 1 over u, x over y, right? It's the reciprocal. Plus c, and then we don't have to worry about solving for y. So that's it.
Would you say u is equal to y over x?
Yeah. Do you see why? Because it's equal to ux.
You plug it in there and negative. Oh, okay.
Because it's
Flipped.
yeah, because it's flipped. Let me pause here. No, I'll stop. Let me stop for a minute and let everyone. It's good. It's been 30 minutes and we've done 2 DEs. That's about right. It's pretty fast. That's faster than normal. Like when we did Bernoulli the first time, it took us like half an hour to do the problem.
We just got to get through it.
Yeah, so I'm going a little bit faster. So, sorry. Any questions so far on this one? Okay, so I'm scared to do variation of parameters because it takes so long. Do you want to do something that's easy for a change? We can do a Laplace. Can I do something easier first? Yeah, I'm do something easier, then we'll do the Laplace. I just want to do something easy. Let's do it. So this is something that is from exam 2, and it's on your review questions, and it might not be super clear what I mean. So this is the one from old exam 2. So it's not the one you took, it's the old version that has solutions. And this is number 6. And the question is y double prime plus what? You only have one of these, so I just want to emphasize that you don't have to be a master, just make sure you. Yeah, so part A was find yc. Let me pause here for a moment, let everyone catch up. So you have some easy stuff on your test too.
Do variation of parameters or the other method?
No, just find yc.
How many Bernoullis did you say there were? How many Bernoullis did you say there were?
Probably just one. There might be 2, but there would be an accident. So there's one intentional Bernoulli.
And then how about the homogeneous?
There should just be one of each, but again, it's intentional that you have one of each. The auxiliary equation or characteristic, good. M squared plus 1. That comes from this, right? Basically, there's a second derivative, so it's a 2. This is the 0th derivative, so it's m to the 0, so it goes away. I don't know if you remember that from before.
Why is there a 0 for 3x sine x?
No, we're finding, this is called the, so we're finding YC. So YC is the solution to the homogeneous equation. So you pretend it's equal to 0. Do you remember? And then you have to find the characteristic equation. So you look at m squared. Remember? So
Why is it 0?
you always set it equal to 0.
We'll be finding YP after.
Yeah, after. Yeah. So subtract 1, so you get this. Take the square root. So you get m equals plus or minus. What would go here in this case? I. Very good. I. You all remember this? Is it coming back? Let me go ahead and write the formula down, because this is review day. So the formula was C1, hey, e to the alpha x cosine beta x plus C2 e to the, Kenny, sine beta x. All right, so that's the formula. So we have to identify alpha and beta in this case, right? So what would alpha be in this case? 0, very good. And what would beta be in this case? 1. Everyone see why? Because it's 0 plus or minus 1 times I, right? So alpha is 0 and beta is 1. Okay, so I'm overcomplicating it just because I'm worried like you don't get it. So I mean, this is it, right? The test is, well, Monday for you all. In my night class, it's tonight. Sorry, so bad. So e to the 0 is going to be what? What happens to that?
1.
That's 1. So you just get cosine C1 cosine x plus C2 sine x. That's it. Part B. So that's part A. And then part B, we have to find the form of YP, and that's it. You don't have to actually solve the DE. That's it. Yeah, because it's time issues, right? So form.
But once we find the YP, it's just YP plus YC, though, isn't it?
Well, yeah, no, you just have to find the form. So watch. So remember this? So this is, so first we did it in 2 steps. So the initial, and then the mod. Do you remember this? Yeah. You only have one of these though, okay? So the initial is based solely on this. So we've got a sine. Hey, John Shepard. So we have to have a sine and a cosine. Yes! Yes! AX plus B cosine X plus CX plus D sine X. I'm running out of room. I have to put my mod somewhere else. So that's based solely off of this. Right, I'll pause here for a minute, let everyone catch up. So.
What is the one called where we have to find the wronskian? No.
Variation of parameters.
That's variation.
Yeah, we can do one later today. It's takes like 20 minutes, but we can do one. Okay, so now you got to see if there's repetition here and here. Is there any repetition? Yes. Good. B cosine x and d sine x repeat with these. And so good, Josh, you multiply the whole thing by x. So you have repetition between b cosine and d sine with these, right? With these, right? With these. So to multiply the whole thing by x. So the final answer is the modified. So it'd be yp. And I'll go ahead and distribute the x. You don't have to. I like doing it. It looks like this. Plus cx squared plus dx. So cx squared plus dx sine x. And that would be, do you all remember this from before? From the past?
No, where did you get the initial from again? I forget.
The initial comes from here.
Okay. Got it. I'm good now.
Okay, and remember, because of the sign, you have to have sines and cosines, because you have to have a linear, you have a full linear in front of each. And the repetition is the hardest part. This was the hardest one, right? Because the repetition's hard to see. You have to multiply it out in your head to see the repetition. You had like 8 of these on your test or something. It was ridiculous. Yeah, Jeff?
How do we know to do it this way instead of using variation?
The question will say find the form of YP. Yeah, and it'll say find YC. Yeah, it'll just ask you. Variation of parameters, it'll say use variation.
Okay.
And it's probably the last question on your test. Yeah, Matthew.
Do you have a list of all the different what cosine equals, like the forms? If
No, not with me.
No, like online.
There's a video, yeah, on the playlist. If you go to the playlist and you scroll down to where it says find YP, method of undetermined coefficients, part 1 and part 2, and then finding the form of YP. That solves the worksheet, the YP video. It's the third one in the playlist.
Maths also.
Yeah, from that. Yeah, it's in the playlist. They're in order. You'll see it. It's there. I can email it to you too if you email me. Yeah, I'll send you the video. Yeah, I worked out the entire worksheet. So hey, Jarrell. All right, Laplace, right? Laplace. And people were, let's do a Laplace. Let's do a Laplace. So full in here. It's like 2 classes. Everyone's here from other classes. So Laplace transform.
Oh, are you gonna give us the Laplace plates for the test?
I can. Yeah. I can print some copies. Yeah, I should print some today. This one, I think this one's easy. So this is 7.3, number 11. Y double prime plus. I picked some of these to help you. So this should be a good one. This is the only Laplace on your whole test, right? Just 1 DE. Everyone did really well on the Laplace transform test. Most people. So I figured that I should not make it super heavy, but make it something, right? So.
And question, the exam is just gonna be differential equations, not like inverse, like.
No, just one, just this.
This is the only class.
Yeah, just this. Yeah, just touching on it, right? Like one variation of parameters. Just touch. It's a final, so and the time, right? This class only has 75 minutes. Okay, first thing you do is you take the Laplace of both sides, right? So solution. So Laplace. Well, I haven't done this since you've done it, so. Plus 2 Laplace y prime plus Laplace of y. Laplace of 0, which is 0. I think we proved that in class one day, right? Like on the side, it was like a remark. Yeah. Oh yeah. I remember where. I think I did it on this board. Yeah. Pitchfork Y, yes, from the ocean. All right, so I was thinking like that weapon that guy in this ocean has. Trident, yeah.
You had like a method to memorize it again?
Yeah, so because it's the second derivative, it starts with S squared, pitchfork Y of S, minus S, Y of 0, and it ends at one less derivative, so it ends at Y prime. That's how I know to put a y there, because it ends at one less derivative.
It's always minus.
It's always minus. Yeah, I had to really think there for a minute. I got confused. You did, yeah, you could, yeah, in my mind. I was confused in my mind. Plus, it's hard. It's hard. Yeah, it's a good test. Like, you have to know DE. Like,
Why
so.
are you putting the zeros in right now?
Huh?
Why are you putting the zeros in right now?
That's the rule.
That's the rule. That's part of the formula.
Oh, you have to.
That's the formula.
Oh, and since y is, okay. Gotcha.
This will be S, pitchfork Y of S, minus what? Do you remember? Y of 0. Yeah, the 0th derivative at 0, so Y of 0. Yeah, it ends at one less derivative. I like how you said that, Josh. He said 0th derivative. The 0th derivative is the original function, right? I always think of that because it comes up in Taylor series. Anyways, plus, and then pitchfork Y, right? Pitchfork Y of S. I love this stuff. I feel like I'm reviewing, like this is good for me too. Like this is a lot of math. Like I wrote these. I was eating breakfast this morning. I wrote these down. I'm like, oh, I should have something. So you can take pictures of this too if you want after class. These problems, but I wouldn't say that these are better than the others. Some of them are obviously, but.
So Laplace of 0 is 0.
Laplace of 0 is 0. Yeah, very good. Good, Veronica. Yep. So now we use our initial conditions. So, they're both 1s. How nice, right? So this is going to be S squared pitchfork Y of S minus S minus 1 plus 2S pitchfork Y of S minus 2, right? Minus 2, because that's a 1. So it's a minus 2. So minus S minus 1 minus 2 plus pitchfork Y of S, and that's equal to 0. 0. Yep, 0. Yeah, 0. Hey, you made it! Oh, good. Hey, I'll put this on the internet like tomorrow or Thursday also. Oh, your test is tonight. Never mind. I'm sorry. I'm sorry. Yeah, I will for my morning class for you all. Yeah, I will. Tomorrow or Thursday. I just have to download it. It takes a while. And then I have to it's like 6 files. Okay. What happens next? We got to solve for pitchfork Y, right?
Yep.
So I can factor it out. So it'll be s squared plus 2s plus 1, right? Plus 1, plus 1. And then this is confusing. I'm going to skip some steps here. This is negative s minus 3. So if you add it to the other side, s plus 3. Very good. Oh, this problem is awesome.
I find it useful moving everything before you plug in your initial conditions.
Oh, interesting. Okay. I mean, you could do that, yeah.
It turns out to be positive on the other side. So you still have to do like 2 plus 1.
Right, right. You could do it that way. Yeah, that works. That certainly works. Good. Now divide by that, solve for pitchfork y. This is like the easiest one in the homework. But it's good. S plus 3. And this is called a perfect square trinomial. It's the name it has in math because it factors. It's s plus 1. Boom. Squared. S plus 1 squared. So we're here. It's a nice problem. This is a good test question.
Now we gotta do that special
It's
trick.
the test question.
We got to do the special. I can't say anything. This is being recorded. So yeah, we have to do that special trick. That's right. So you really want it to be an s plus 1. So you just do whatever you want and you put it there because we can do that. Plus 2 because you're trying to get 3. So you write down the 1 because that's what you want. So we're trying to get a 3. So we add 2. I love that special trick. It makes our lives so much easier. So you write down what you want and then you fix it later. You have a 3, so you just add a 2. It's beautiful, isn't it, Kenny? No, I'm just looking at your face. Or is this YMS? These cancel. It's 1 over.
Pitchfork y of s.
Huh?
Why do you say pitchfork y of s?
I don't know.
We don't know what that letter's.
Wait a minute.
Pitchfork of s, right?
What'd you say? It's just what?
He isolated it over here.
I don't know, pitchfork's easy to remember. It's fun.
Yeah, why? Oh yeah, why not just say y of s or psi of s?
Come on, guys, let's keep going.
Pitchfork y. Yeah, this is pitchfork y of s. I don't know. It's really bad. Okay. So what's going on? This is the Laplace of y, right? That's what this is, just for some understanding. So the Laplace takes y and sends it to this. So the inverse Laplace takes this and sends it back to y. It's the inverse function. So to finish, all you have to do is take the inverse Laplace. So y is equal to the inverse Laplace of 1 over s plus 1 plus, pull out that 2, inverse Laplace of, oh, you know what? This is going to seem hardcore, but it's okay. This is how we do it.
Translation theorem.
Translation theorem. Let's just do the shift, right? Because this one's an E. You can do the shift here. This one's in a formula sheet. Yeah, David? Okay, I thought I messed up. Okay. This one you can do a shift too, but it's on the formula sheet, right? And this one we do a shift because it's squared. So this one's going to be e to the negative t, right? Because it's s minus a would be e to the at, so it's s minus negative 1. So it's e to the negative t plus 2. This is 1 factorial. So it's going to be t, right? T. And then we did a shift. So it'll be e to the negative t. Yep. And that would be the solution to the differential equation. It's e to the negative t because of that. This one? So this one has a factorial, right? So it's 1 factorial, so it gives you t to the 1. So like, check it out. Check it out. Say it was inverse Laplace, 3 factorial, s to the 4, s to the s minus 6. That would be t cubed e to the 6t. Because this gives you the t cubed, and this gives you the e to the 6t, the shift.
And then what if you were not doing inverse Laplace? I don't know exactly what the shift, but let's say you just were getting the Laplace of a function like this.
Of this,
If you get the Laplace of that, you end up with.
you drop the e and becomes a shift.
Oh, right, the E becomes.
The e becomes a shift, but that shouldn't come up
Okay.
because it's just this. Yeah,
How'd you turn 2 into 1 factorial?
I pulled the 2 out,
Oh, okay.
and then I wrote the 1 factorial. Yes.
We're going to be getting the Laplace formula sheet.
I can bring a couple extra ones if you need it. Yeah, sure. Yeah. But this is, if you could do this one, you're pretty much ready. Like, it's very light on Laplace. I figured it's a final, and it does replace your lowest test. So I had to justify that somehow. So I had to put something with Laplace. Like series, you only have 1 series question. Like an easy one, like just one series. It's an easy one. Everyone should get it right. So we have 30. Yeah, we have time. Okay, did that. Hold on, let me cross stuff out. So we did the Bernoulli. Wow, we did the Homo. Let's do an exact because it's like.
And let's not forget to do a variational parameters.
Okay, let's do. Oh wow, I crossed out the exact. Huh? Let's do it. Yeah, let's do it exact first because that's shorter. Then we can do variation if you want. Yeah. I feel like we've done a lot already. Like it's quite a bit. Like feels pretty good. Like I'm feeling better about the test. 2.4. I saw this list. I'm like, there's no way we're gonna do all this. We've done really well. So this one is really evil. This was on a final before, and I remember a bunch of people got it wrong, and I'll tell you why. dy equals 0. So this is one of the review questions. This is 2.4, number 6 from the homework.
Isn't that homo?
Yes, it's a homo also. And if you do it the homo way, it's really hard. Like, it's super tough. So
That we're doing?
we're going to solve.
No, but what's the?
This is going to be exact. So we're going to... Yeah, but it is M&N. It is homogeneous. So Matthew said it is homogeneous. So if you do it the homogeneous way, you will get the answer, but it's really hard. Okay, like it's more work.
Don't do it that way. We don't have so much time.
Right. So what you want to do on the test is always check to see if it's exact. So always do that first. Okay. So this is our M, and this is our N. I'm having deja vu because we kind of did this in Calc 3 the other night, right? Oh yeah, you're in Calc 3. Yeah. So del M, del Y, right? So you have to work that out. It's the other variable. It's how you memorize it, right? There's an X, you put a Y. Yeah.
I have a brain fart clued over why it's exact or not.
Well, we're going to check.
Okay.
So to check if it's exact, you call this M, you call this N, and then you compute del M, del Y. It's the other variable. So it's going to be 6y to the 5th. Okay. Now we have to compute another partial derivative. That would be del N, del X. Very good. Because it's the other variable, and it's the same, so it's exact. So exact.
That's how we check it.
And it's not going to be a tricky one. I think you had one on your test with an E that required the product rule. Was that your test?
I don't remember, but you're not going to say, like, this is an exact D.
No, it won't say.
Okay.
And as Matthew pointed out, it's obviously homogeneous because look, 6, 6, 1 plus 5 is 6. But don't do it that way, right? It's harder if you do it that way. Yeah, it'll just say solve, and then you just cross your fingers, and then just, yeah, okay. So whenever it's exact, let's do it the cheesy way. I'm going to write it again up here. Just going to copy paste it. Can't really copy paste. We don't have those powers in real life.
How do we know that we're going to be solving for? How do we know when it's going to be homogeneous or when we're going to be solving it this way?
You don't know. You just have to.
You have to be a math god.
Yeah, you got to be a math god. So, huh? No, just say solve.
Well, I mean, you can always just check and see if it's exact. Exactly by doing it.
Yeah. Oh, for those of you that walked in late, on the test it will say explicit solution. Don't worry about solving for y. Just implicit's okay. So, okay. Integrate this with respect to x. So it'll be x to the 7.
If you're going to do the exact, you can always solve it this way, right?
Yes, exact is easier too. Plus, integrating with respect to x. So integrate with respect to x. So int, all right, int, wrt, x. I feel like I should put a period there, but I won't. No. Integrate with respect to x. Integrate with respect to x. Integrate with respect to x. It's really fun, but I won't. Okay, that's dumb. Okay, and this is x, y to the 6, plus an unknown function of what variable?
The other one.
G of y, the other one. Very good. And that's equal to. It's been a long time, right? It was like September, right? Integrate this one with respect to y. Very good. Oh yeah, the 6's cancel, right? So we just get x, y to the 6. It's over 6.
Plus h of x.
Plus h of x. That's right. Let me pause here. So we integrated this.
Now we do it the new way, and we just write everything once.
Yes. Yes. The what way?
The new way.
The noob way. Yeah. It is. Yeah, it is. Because yeah. Any questions? Yeah.
How do you know which side to integrate with x and y?
So the easy trick. So whenever there's an x, just integrate with respect to x. Good. Whenever there's a y, integrate with respect to y.
So your differential will tell you which one to.
Yep.
Yep.
Recap. You're taking the test to see this question. Yes, it's homogeneous. Don't do it that way. Check to see if it's exact. Find del m, the other, del y, del n, del x are the same, so it's exact. It's always the other variable to check.
What is this question on the exam?
I don't know. You'll find out.
You can only solve this way if they're homogeneous.
If it's exact.
Oh, sorry.
Right, if it's exact.
Any of them always. It's exact.
Yeah. So integrate with respect to x. Get this. Add an unknown function of y. Integrate with respect to y. Add an unknown function of x. All right, here's the key part. Now you write the answer down, right? Left to right. So you write that down because you see it.
Now is it f of xy again, or?
Yeah, it's f of xy equals c. So I'm writing down here the f of xy. So then it's this one. Ignore it. Oh, we already wrote it down, right? So the answer is equal to? What do you put here? Do you remember? C. That's the answer.
Wait, what?
Yeah. All right, let me explain it again.
That's the only part I don't understand.
Yeah. I'll explain it again. So you write this down. You write this down. Right? So you write it down, ignore it. Oh, look, you already wrote that down, so you don't write it down again. Let me explain why. The reason this happens is as follows. This is equal to f of xy. This is equal to f of xy. So we basically have an equation that's saying f of xy equals f of xy. It's like saying 2 equals 2. Duh.
Why in calculator did we call it f of xy equals?
It was different. It was a different question. Remember, it wasn't an equation in that case. It was a function.
So could we write as an answer f of x y is equal to x to the 7 plus x y to the 6 plus c as an answer to this problem?
No, it's an equation. No, write it like this. Write it like this, because if you remember, this equal c came from the fact that it's equal to 0. When we had the total differential, the dz was 0 because c was a constant, so it's a little bit different. So I wouldn't. You could do this. You could do f of xy equals, because the final answer is of the form. It has this form, the final answer. And that's because of the way everything was constructed. Remember the DZ and all that? Yeah.
Do you have an old finals test?
No, I don't.
Specify f of x, y. Are you gonna?
No, you don't have to specify it. That's.
So
Okay.
the way, so if we see one of these, our first step should be, okay, are they exact? If they're not, are they homogeneous? If they're not homogeneous, are they Bernoulli? Game over.
Game over! Yeah. Well, you'll know the Bernoulli, right? The Bernoulli will have that y to a power, right? So you got that one. You've got the homos down in exacts.
Since f of xy equals c, is that correct? Is that a correct statement?
Yeah, you just put equal to c. Yeah, at the end.
Equal to c.
At the end, just put equal to c. Yeah, that's good. We did the homo. I don't think we need to do a linear, right? So what did we do? We did Bernoulli, exact, homogeneous, Laplace. Oh my God, we've done everything.
Variation.
Variation, you want to do it? Yeah. All right, let's do it. I have 2 of them on here. I'm not sure which one to do. The hard one? Yeah. Okay, all right. Well, no, we didn't do linear and we didn't do series stuff, but they're easy. You know how. So 4, 6, number 5. How many of these? Number 1.
Okay. Yeah, we missed these.
Y double prime plus 3y prime plus 2y equals 1 over 9 plus e to the x. As you write it down, I'm going to see if I can look. I'm going to look at the test really quick. See if I can find it. Yeah, this one's on your old test. Okay, this one is on old exam 2. So you have the answer to this one, except there's a 1 there on the old exam. But it's the same problem. It's the same problem. Okay, so it's been a while since you've done this, so solution. So the first thing you do is you solve the auxiliary, yeah.
What is this for?
Oh, it'll say variation of parameters. Yeah, thank you. It will tell you, by the way.
Oh, this one is almost like wronskian.
Yeah. Yeah, it's probably the longest thing on the exam. So first step is you write down the characteristic or auxiliary equation. So it'd be m squared plus 3m plus 2 equals 0. That's the first step. And then you have to solve this. This usually factors, I hope, nicely. Let's see. So it's m plus 1, m plus 2. Yeah, m plus 2. Very good. M plus 1, m plus 2, and that's equal to 0. I'm going to write a little bit small. It's all right. So we get -1 and -2, right? -1 and -2. So we get m equals -1, m equals -2. I think there's going to be a lot of good grades on this test. Now that we're reviewing, it's really good. I haven't reviewed for this final, I think, in years. It's been like,
E to the negative x plus x e. Oh no, not that. Yeah.
plus C2 e to the,
Negative 2x.
very good. Good, Matthew.
The
Yep.
only time you add an x in front of it is when you have
Repetition. Which might not even come up. I mean, so now we have to identify y1 and y2. So this is our y1, this is our y2. If you mix them up, it's okay. Okay, so y1 is e to the negative x. y2 is e to the negative 2x. Okay, and now you have to take the, do you remember? The primes, yeah, the derivatives. Very good. So y1 prime, this is B pro here. We're going to get a negative because of the chain rule. So it'll be negative e to the negative x. And then y2 prime will be negative 2. Oh, someone's integrating.
Yes, I did.
Did you do it too? Oh, it's okay. All right. So now you got to find the wronskians, right? You have to find W, W1, W2, all of that stuff. So W is the determinant of, and then it's just this. So it's e to the negative x. It's just the wronskian of y1 and y2. E to the negative 2x, so it'll be here. I'm really impressed with how much we accomplished today. Like, I did not think we would do this much today. Like, I'm like shocked. We actually did a Bernoulli, a Homo. I feel so, I can't believe we did it. Like, I was like, there's no way we're gonna, yeah, wow. Okay, let me just stop talking, let's do this. So W, so get this one wrong, not finish it. So this times this, negative 2, you add the exponents, right?
Yeah.
So e to the negative 3x. And then minus this times this. Oh, but it's already minus. So it's plus. Like that.
So you're going to be left with negative e to the negative 3x.
Uh-huh. And I'm going to put this in a box because this is a huge accomplishment in our lives, right? So.
Levi, you are friends with legends. She talks about you all the time.
Oh, Levi. Yeah, this is Levi. Sorry. Yeah, no, it's, yeah. Have I mentioned him before in class?
Oh, like all the time.
Really?
Yeah.
What did I say? That doesn't matter. Okay. All right. So W1. Don't let it get to your head, Levi. W1. W1. So for W1, you take the.
Oh, it's going to be a 0 and first one 0.
Good. Good. You replace it with this. So replace the first column with 0 and f of x. So you do 0 and then. Did I copy that down right? I did. Okay. And then you keep the second column. Okay.
Was it always 0?
Always. It's always this. Okay. So let me go over that again. So for W1, you replace the first column of the wronskian with 0 and f of x, right? Always, every single time. And I guess we'll do it. So that's this times this, so it's 0 minus, and then this times this. Oh, yuck. E to the negative 2x, and then 9 plus e to the x. Okay, I'm going to write it again over here, and I'm going to put it in a little box, because it's really nice to box stuff. It's always nice when people like box stuff. It makes it easier to grade. It's always nice when people have good handwriting too. I have bad handwriting, but
W2.
W2. That's the thing you do at the end of the year, right? Yeah. You get that if you have a job. Don't they give you that? So you keep the first one. I'm not going to, but you can. And then you replace the second column with 0 and f of x, right? The second column. So it'd be 0 and f of x over here. So 0.
This is the opposite.
This is the hardest one. I think this is the hardest one in the homework besides number 7. I didn't assign 6 and 7 as review questions because they were just not fun. This times this minus 0, so it'd be e to the negative x over 9 plus e to the x. So we have W2 equals e to the negative x over 9 plus e to the x. So that would be W2. There's a lot of points here. This is one of the 6 questions on your test, this variation. So it's probably like 20, 30 points. Out of, well, no, I don't know about that. You got this. Okay. What do we do next? Oh, we have to find the u's now, right? U1 and U2. That's what we have to do, right? The u's. So U1.
It's the fun part.
Yes. Yes, it's the fun part. I know, just getting started. I gotta get some water. So U1 is W1 over W. So W is over here. So when I'll write it. So it's going to be, so W and W1 are both negative, so it's going to be positive. Okay, so this is W1. So I wrote down W1. We're dividing by W. So when you divide by W, yes, you multiply by e to the 3x, which is the reciprocal. Is that okay? Can I do that?
Just write down W.
Wait, is it a negative?
They're both negative, so they cancel. Good question. Good question. So I did skip some steps here. Because we divided. So we divided by W. So when you divide by W, you multiply by the reciprocal. So I skipped some steps here. So good question. No, ask.
Seriously, I was like,
Yes, Jarrell.
Oh, no, I was what it is.
It's the negative 3x, isn't it?
No, we divided by this, so you multiply by the reciprocal.
Oh, okay.
I skipped some steps, sorry. I should have just shown the step. So basically, the negative and the negative cancel, so it's positive. When we divide by this, we multiply by the reciprocal, which is, Kenny said it, so I wrote it.
Because e to the x.
Everyone see how that's okay? Everyone okay with that?
Yeah, no.
Let's clean it up.
Can you show it?
Okay, I'll show it. So I'll show every step. So sorry, Kenny. So it's W1. So it's 9 plus e to the x, and then divided by W. So it's times 1 over negative e to the negative 3x. It looks ridiculous if I show it. See, it's worse.
Why do you do that?
Because we're dividing by W. Because that's the formula. And that's more confusing now, right? I know. So this is equal to, it makes it harder for me. So now we bring it upstairs. That's good, because you don't want to mess up here, because that's bad. And then this is equal to e to the x, 9 plus e to the x dx. And what was this called? This is U1. This is a trivial integral, right? You let u be the bottom. Yeah, Jarrell's right. You don't even need the absolute value because it's positive, so.
Wait. Oh, you're just skipping to that step. Okay.
Yes, wanted to do that. Yeah, so you can call it u. The derivative is the numerator. It's an ln with an absolute value, but you don't need the absolute value because 9 plus e to the x is always positive anyways. So you can drop the absolute value.
Always happen when we have something nice like that.
Yeah, it's rigged. So I'm gonna come to this board now.
How come we don't need the plus b for this?
Everything goes away if you put the plus c. It'll get absorbed at the end later anyways. So you could try it, and you'll see it just all goes away. Now we got to find U2. This is where it's going to get harder. But any questions on U1? We still have a couple minutes, so it's good. All right, U2 is W2 over W. So W2 is way down there. It's over here. It's this one. And so we're dividing by W. So this time, let's just go ahead and skip that step. We're going to multiply by, we're dividing by this. So it'll be negative. So it'll be negative e to the 3x times W2, which is e to the negative x over 9 plus e to the x dx, right? So it's this one divided by this one. So when you divide by this, you multiply by the reciprocal. Again, the same thing happens.
You just brought it upstairs to that next power.
Right. So this is the step which I'm glad Matthew asked, that I showed. It's the same thing happens over there, and you bring it up, and it becomes positive. So that was a good question, Matthew. It's good.
Good job, buddy.
Yeah. So this is going to be U2 equals negative e to the 2x, and this is where people give up. Yeah, you can.
You can call that. Yeah, you can say u is equal to e to the x, and then e to the x is equal to
It's not like a simple
u minus 9.
Yeah.
And then you get u minus 9 du over.
Yeah, you could do it that way. I'm going to do it a little bit different, but you could do it that way. You could. So you could make a U sub and do it. I'm going to, yeah.
W negative 3x?
Yes.
Yeah.
Yes.
Oh, it's divided though, so.
Well, I mean,
We're dividing it, so we're bringing it up. Power.
See, when you divide it does that, and then when you bring it up, it becomes positive. Same. It's good. It's really full. Any questions? Make sense? All right. Hey, you know what? After the test, it's Christmas. Right? Just like enjoy your life. Although this is kind of fun. Okay, there's a couple ways to do it. Jeff had a really good idea his way, but I'm going to do it my way just because I don't want to mess up. We only have 10 minutes. I want to take a chance in 10 minutes. So my idea was to come to the side and do this. So rewrite it like this. Right, because e to the x times e to the x is e to the 2x. And then you could do this. You could split it up like this. So you have e to the x over 9. Remember this?
Yep. Yes.
And then you add 9 and subtract 9. Remember this trick? So basically now you put a plus 9 here. Then you have to do a minus 9. Remember that? This is what legends are made of. This is like mathematics for the soul. So basically you're here, right? And then you add a 9, because that's what you want. And then maybe at the end of class we'll do it Jeff's way. And this is 1 minus 9 over 9 plus e to the x. Right? Everyone's
Just pull out negative e to the x.
Why'd I pull it out?
Well, how can you just pull it?
Oh, because e to the x times e to the x is e to the 2x.
Okay. Right, yeah, I got that.
That's all I did.
Why isn't it negative e to the x over 9 plus e to the x?
I'm sorry, I can understand.
He called it that and then he fixed it with the other. He called it that and then fixed it with the
I
other.
think I understand.
So we're here. And then, oh, you mean here? Oh, I put it out here, so we're here. The same thing. Then we want a 9 here, so we put it there. And then we take it away.
True statement by putting that.
I think
Yep.
I figured out my problem.
Okay. So now let's come back here. So u2 is going to be negative e to the x dx plus 9 e to the x, right? It's going to be plus now. So plus 9, right? Because it's plus 9 e to the x over 1 plus e to the x dx. So that's this times this. Now you distribute and you're here. So it's just a clever trick to take this and write it like this. This is a really hard integral.
You already know the integral, the left one.
That's right. That's right, we do, because we're pro. But let me pause here, because this is like the hardest part of the entire problem, right? This is what makes this problem hard. Yeah?
Why is it over 1 plus e to the x?
You know what that's called? That's called a mistake. Thank you. Were you raising your hand too for the same thing? Okay, I'll get you after class. I'll give you the points.
I think we all saw it though.
No. What's up? Yeah. Huh?
You just plug the 9 and then just do e to the x over 9 plus e to the x.
Yeah, or you can do a, well, this one's easy. Fail, I'm falling apart. This one's easy. This one, you do a u sub though, right? For this one, Veronica. So if you wanted to do it, I'll do it up here. You would let u equal 9 plus e to the x.
Okay.
So du is e to the x dx. And then so this just becomes 9 du over u. Right, and then it just works out. So this is,
We have the integral for e to the x.
yeah, we have it.
So we just
Yeah, so we just do that. Almost done. We have 6 minutes, we're gonna need them. We need these 6 minutes. Jeff had a really good idea, by the way, and it does work. Jeff's idea was you do this, okay? And then you have to think about it like this, and you could do it with this substitution. It will work, right? Because your du in this case is e to the x dx. That takes care of one of the e's, and then you solve for the other e. You get u minus 9 and you plug it back in. So Jeff's method is a very legit method, and it's very organized, and it works. So good, Jeff. I just want to emphasize that your way is really, really good. I was just scared to do it because we only have 6 minutes. And, huh? So now what's the answer? So now we go to find yp. So I'm going to come back here. So finally, so now yp, we're getting there, is u1 y1 plus u2 y2. Fun times. I think this is one of the ones that doesn't simplify. Oh my God, it does. Nope, we need every minute. So that's yp. It's a good test question. Okay, so now you plug everything in. So u1 is way over here. It's this ln 9 plus e to the x, right? So it's ln 9 plus e to the x. y1, I erased it with my hand. You can still see it. There's a faint survival piece of it there, right there, e to the negative x. u2 is that ridiculous thing we found earlier. So parentheses, negative e to the x plus 9 ln 9 plus e to the x times, and then y2 is here. It's e to the, was it 2x or negative 2x? I think it was negative 2x. It was negative 2x, yeah. So that's yp. That's the yp.
Done.
No, not yet. Not yet. Not yet. So now we have to find y. So y is, do you remember what it is? It's
YP plus YC.
yp plus yc. Before we do though, I'm going to just distribute this. I know it seems ridiculous, but it's going to be necessary in this problem. So I'm going to write it one more time. So yp ln, it's kind of sad, like this is it, you know, dE is over. This times this, you add the exponents, right? Yeah, you should, because it's going to simplify at the end, Isaac. How do I know that? Because I looked at the answer. 9 e to the 2x. I have it up on the thing. It's on the old, yeah.
It shouldn't be absolute value anymore.
You don't need it. You can have it. It's fine to have it.
No matter what you put in, it's going to cause it.
Yeah, it's gonna, yeah. So finally, let's make it seem long and dramatic. Finally, we have arrived. No, I won't write that. So y equals yc plus yp. All right, yc plus yp. So I forgot what yc was, because it was the one with the c's. What? Thank you. E to the negative 2x, right, Jarrell? Thank you. And then I'm going to write all of it again. I know it sounds ridiculous. I'm going to put the e in the front because it's just bothering me. ln 9 plus e to the x. Writing fast. There's one more step after this and we're done. Minus e to the negative x plus 9 e to the negative 2x. ln 9 plus e to the x. Almost done. Let me just pause. I can write faster with my marker than you can with your pen or pencil, probably. I read somewhere on the internet that people can write faster with markers.
Yeah.
Is that true?
That's why I don't do
Maybe.
pencil math.
Some teachers write really fast. I've seen, yeah, there was this guy in my office one day, he was writing integral signs like this. I couldn't even like, it scared me how fast it was. Like, Any questions? Any questions? Like, no, we're not done. There's one more step. The problem will say simplify your answer as much as possible in bold. So I think there's a common term here. E to the negative x. Yeah, so in theory, you could take this one and take this one, and you could write it like this. C1 minus 1 e to the negative x. C1 is arbitrary. It could be any number. You subtract 1, you still don't know what it is. It could be any number. So just call it C3. So this is going to be, so combine these and call it C3. E to the negative x, ln 9 plus e to the x, plus 9 e to the negative 2x, ln 9 plus e to the x.
Yeah, can you combine those two together in the parentheses and group them?
It's not necessary though. Nothing will simplify. You mean these here?
Yeah, you just combine with less writing, I guess.
Yeah, less writing, but you could.
Rather you see one is to simplify as much as possible.
That's not simplifying though. Simplifying is, go ahead.
Question, you want to, so you combine the e to the negative x by combining e to the negative 2x.
There is no other e to the negative 2x.
Yeah, now you
It's got an ln.
Where'd that go? Oh, it's right there. That's it.
Oh, and that one was just a number. Got it.
Good question. So how did you simplify? Good, I'm glad you asked. So basically you look at these and this one, and they're common terms, right? So what you can do in your mind is you can pull out the e to the negative x and write it like this, c1 minus 1, right? Because c1 e to the negative x is there, and then negative e to the negative x is there, right? So then now what you can do is you can just rename this, because you can rename constants, remember? So this is c3 e to the negative x. So it's like if you had c2, yes. So it's like if you had c2 e to the x, e to the 3x, plus 4 e to the 3x. In this case, just combine them and call it c3 e to the 3x. The same. Any questions on this stuff? All right, that's it. Good luck. Good luck. We'll turn this off.